Testing, testing. Once again, Wickerson Studios. Michael Wickerson here. I'm going into continuing with the Python node. Nice simple script here. As you can see, I've done a little bit of funkiness to jazz it up. If you're interested, the Patron membership, you can get access to the GH files on GitHub at mwickerson. Otherwise, you can just take a look at this. Pretty much you have it. However, there is some post node fun. And what I've ended up doing is creating a kind of cup and saucer combo that's based on conditionals. So when one changes, the other one changes, and you can follow through the maths and try and figure out what's happening here. I'm also using Rhino script syntax still and Rhino geometry, creating 2 point lists, A and B, and I'm doing an iteration through X and an iteration conditionally, depending on X and Y as integers. So make sure you do your type hints integers on X and Y. Step is a float, so you can actually change that for the size of the base, which is kind of fun to play with, and you can see the relative changes. And then the conditionals have effect when you downsize one. You don't really get a base with it. If you want to have a bowl for that to sit in, you can make the other one. You can change this form, and you can see how they kind of pair against each other. And I think it's kind of cool to create two geometries at the same time that kind of mimic each other and play off. Obviously, I'm in here having a little bit of fun with the maths. Not too hard, playing with, not hard coding numbers, but actually playing with the inputs to have an effect on that. And the only thing I really did different was used RG and RS here just to keep, the learning curve open for myself if I wanted to do that. So the script's fairly simple in Python. It comes from the general conditional script that's much smaller in the GH Python notebook I'm looking at. But once that's done, let's have a look at the Grasshopper. You're outputting 2 points, series of points. So if I take this on, you can see the points being generated there, and you can see the points being generated here. They both are revolved around the same axis, which I think I have in here somewhere. I just have to find out where it is. Axis curve from these points. I think it's so small because the length. So if I upsize the length, so length 12, I think we'd actually visualize that line. There it is. So I could actually see the axis that's being revolved. It's too small to note. So you get a point system. You get a point system which is interpolated. You get this one interpolated. So these two interpolated revolve around that and that, make the two different forms. I debrep them. I grab a list length. I put a surface on it to cap the bottom. And then I leave the other one in this position, whereas the other one I just do a quick move. And you can have fun moving that as far away or underneath. So if you actually want to pair them both up again, as you look into your scripts, if you actually want to see if that one sits nicely in there, you just put it back in there, and obviously it doesn't. I'd have to drop it in the Z direction. But otherwise, it's a nice little system for pairing cups, making what I think is choices to optimize forms, decide what you want. I've gone in here and done a little multiplication. Obviously, the 2 here, I can change slightly. I can hard code. I can put in more variables if I wanted to. So Z, I can put in here as, let's say we put in Z. And the main point of this is to get you thinking. Let me grab a slider, which was 2. Make sure I set my type hint to integer. Pull that in. Let's see what happens to the geometries as I move this out. What happens to the geometries as we run it? There we go. I'm running it a bit. You can see I have a little effect on the Z in the top one just to play off of that instead of leaving it at 2. So once again, I don't like to hard code anything in here. I like to really play with my inputs, play around with the Python node. And then the outputs are back to where I was on single iterations in Grasshopper, maybe dependent on a number slider, but I find it much more interesting to have number sliders influence the Python. And this, to me, is modeling. This is absolutely digitally modeling with Grasshopper and Rhino, but dipping into that GH Python node. And you're literally on the introductory chapter, not even past page 40, going in and finding these base scripts, but realizing that a lot of the manipulation you were doing in nodes, which can get a little unwieldy as a can of worms or spaghetti, which some have experienced. I haven't put anything in here. I could take any one of these surfaces. I believe they're, let me check what they're called. Oh, that's not going to tell me. Let me grab a little panel tool and see what we're dealing with here. We're basically dealing with untrimmed surfaces and a trim surface, top and bottom. Well, I can pull in any of my surface along normal scripts if I wanted to do that and extrude them along normals afterwards. But right now I'm kind of finding out where my interest is. And currently my interest is in getting my nose into the Python, very simple scripts, and then optimizing it kind of computationally or generatively trying to figure out. Now, that's not using any machine learning. I'm still kind of using my own sense of aesthetics as to what I'm building, but doesn't that happen when you work in bronze or wax or clay? That's basically how I think. So to me, it's a sculpture class, digital modeling course based in Python, the GH Python nodes, basic Python understanding, which you can see it's not too hard, dealing with simple functions once again. And we're going to go from conditionals 1, and we're going to go into probably dealing with arrays, 2D array of points, an additional conditional, and then into a random library. And things are going to get real complex real quick within the Python nodes, which is what I did in my first series. So if you are interested, please jump on Patreon to take a look at these files if you don't want to try and create them yourself. I really think it's a sense of just understanding the basic. It's customizing the Python node within the Python node to what you want to play with, sculpt with that initially, and then do the post effects with all the skills that you've mastered in introductory to intermediate Python skills. And I'm not sure how many out there are interested in sculpting this way and building forms this way. I think there should be, and you're just a step closer to the optimization and generative programs that are out there and allow the machine learning to decide a lot more for you. What you have here are some great forms that you can just quickly make. Let's take them both. Actually, I wonder what happens when you select both and bake. I haven't really ever tried that. Nothing. So you got to grab one at a time. I never even do that. Let's just grab one, do a quick bake over here. There it is, and maybe I baked it. Oh, it's my turntable that's causing trouble. Actually, I want to try that. Let's try a quick bake on, there we go, bake them both at the same time. And there are plugins for doing that, but you've got two nice forms here. You can take a look at them. Let's pull them back into rendered, or actually pull them back into shaded and see what we're actually dealing with. You have these interesting twists and turns and forms that are made. You can kind of explode these and find out what you want to do with them. But do those work together as cups? Well, they're conditionally, maybe they do, and maybe you're not liking what's happening. If you don't like it, just move them out of the way and jump back in there to your conditionals, make some adjustments. You can place some adjustments there. You can also, what I like is you can set the X above Y and the Y below the Z, and you can actually play off of some interesting forms as they go. And that's all dependent on how you're building those 3D point systems. Like those two, from the exact same script, I can come back in here and say, oh, well, there's something I found and discovered. And this is, of course, digitally doing it without materials, limited time, quite a few iterations are available to you. And there we go. We get another sense of a cup and bowl. And if we wanted to see those two, I'm going to pull them up and out of the way. But if we want to sense if the other one is underneath, you just drag that one back over and say, oh, look at how that form fits nicely on that little cup. Do you like that? And if you don't, well, move it aside and pair the next one with the other one. So not just creating two objects at once, this can quickly be extended through other iterations and other formulas into producing hundreds, if not thousands and millions of the same things at the same time. So wrap your head around this, wrap your head around sculpting, digitally sculpting with Python, with coding and programming, and the next thing you know, you've got to jump on anyone else that's sitting there kind of, single iterations at a time in their studio. And not that speed is all important. I think the tortoise really does win out. But you don't have to make everything you're looking at. It's just nice to be able to visualize data and visualize forms before getting into the actual physicality of taking these castings into bronze, aluminum, and clay, and other materials, plastics, carbon fiber, whatever you want to extrude. So thanks again for watching. Michael Wickerson at Wickerson Studios. Onward.